Sir, may I ask you one previous year question, sir?
Yeah, please.
ஒரு டவுட் இருக்கு சார்
எதுல
capacitance.
சொல்லு.
Sir, can I forward you the question? கொஞ்சம் பெரிய
That's better.
question.
Forward பண்ண அப்புறம் then I'll discuss with you. I'll look into it and discuss. Whether time waste பண்ணாத.
சரி, ஓகே
Class
சார்,
முடிஞ்சு.
ஓகே.
I'll look. But forward.
சரி. ஓகே.
Okay. Yeah. Siri, we'll get started. Right? Listen. Harish, you're there?
Yes, sir.
Okay. So we'll get started. Listen. So ray optics basically has another name. What is it? It is also called as geometric optics, and you have been reading this chapter since your 10th standard. You know what is the light? You know what is light? You know what are the characteristics of light? You know what are all the important terms that are related, right? So you talk about objects like luminous objects. So luminous means what? The objects which are able to emit light on their own are called as luminous objects. Example, sun, other stars, an oil lamp, etc. are luminous objects. Non-luminous means which do not emit light on their own, but become visible due to the reflection of light falling on them, are called non-luminous objects. Example, moon, table, chair, trees, etc. All these are non-luminous objects. Then we know what is a ray of light. A ray is nothing but a straight line drawn in the direction of propagation of light, is what we call it as a ray. So the definition of ray in the next chapter is an arrow mark which is perpendicular to the wavefront, is what is called as a ray, right? That we will see in the next chapter. Next is, you know what does a beam of light mean? So the bundle of adjacent light rays is what we call it as beam of light. So you can talk about parallel beam, you can talk about a divergent beam, or you can talk about a convergent beam of light. Then image. So if the ray coming from an object meets or appears to meet at a particular point after reflection or refraction, then we call it as image. So what is the real image? If the real meeting of light rays takes place, then we call it as real image. So real image can be obtained on a screen, and real image is always inverted. These are the two important words you need to have in your mind. So whenever you see they will give you an example. They will give you a question like this. There is an image formed due to reflection which is inverted. So is it a real image or a virtual image? So instead of saying it is real, they have used the word inverted, because real images are always inverted. Then what can you talk about virtual image? The image obtained when light rays are not really meeting but appears to meet directly is what we call it as virtual image. Okay, virtual images are direct in nature. So have this point in your mind. Next. So what is reflection of light? The rebouncing back of light rays into the same medium on striking a highly polished surface such as a mirror is what we call it as reflection. So this year, if you see in your CBSE, they have removed reflection, but for JEE it is an important concept, because you might have a combination of lens and mirror taken into consideration. Lens is an object which will refract. Mirror is an object which will reflect. So you need to know reflection also with clarity. I will go a little fast in terms of basics, but I'll explain the problems in a better way. But if you have any doubt in the concepts, please stop. Okay. So laws of motion, laws of reflection, everybody knows, right? There are two laws of reflection. What are they? The incident ray and the reflected ray and the normal all lie in the same plane. The angle of incidence is equal to the angle of reflection at the point of incidence. Right. Next is, what are the types of reflection that you can have? So you can have regular reflection when parallel beam of light rays reflected is obtained from a parallel beam of incident light rays after reflection from a plane reflecting surface. Then such type of reflection is what is called as regular reflection. So other one is called as irregular or diffused reflection. Diffused means diverting from their actual path. When a non-parallel beam of reflected light rays is obtained from a parallel beam of input rays, then that kind of reflection is called as irregular or diffused reflection. So what are the objects which have the tendency to reflect? They are mirror. So what is a mirror? A smooth and highly polished reflecting surface is what is called as a mirror. So there are different types of mirrors we can talk about: plane mirror and spherical mirrors. So plane mirror means what? A highly polished plane surface is called as a plane mirror. So what are the different properties of a plane mirror? So different properties of image formed by the plane mirror are given below. Size of the image is equal to size of the object. Similarly, magnification is one. What is magnification? It is the size of the image to the ratio of the size of the image to the size of the object. So distance of the image from the mirror is equal to the distance of the object from the mirror. So plane mirror will always form a virtual, plane mirror may form a virtual as well as a real image. Say a man may see his full image in a mirror of half the height of the man. So have this point in your mind. There will be a problem based on this. At that time, we'll have the proof of it. So if a man sees his full image in a mirror of half, a man may see his full image in a mirror of half height of the man. Suppose the man is 6 feet height. If he wants to see the full image of him, what should be the size of the mirror?
3 feet.
That's it. That's what they're trying to say. So 6 feet man can see an image in a mirror which is of size 3 feet. Have this in your mind. Okay. All these things can be proved. Okay. Similarly, this is another important point. When you have two plane mirrors which are held at an angle theta, please make a note of this point. Okay. The number of images of an object placed between them is given as below. So the number of images will be 360 degree divided by theta minus 1. If 360 by theta is an even integer, and n is an integral part of 360 by theta if 360 is an odd integer. So have these points in your mind. So these are the number of images that can be formed when two plane mirrors are inclined at an angle theta with respect to each other. If you keep an object here, then the number of images of this object formed is how much? 360 by theta minus 1 when n is when 360 by theta is an even integer. It is only 360 by theta. That is an integral part of 360 by theta when 360 by theta is an odd integer. Have this point in your mind. Okay, next. If keeping an object fixed, a plane mirror is rotated in its plane by an angle theta. Okay, so let's say you have a plane mirror and there is an incident ray. Okay, if this plane mirror, so if this is the object, so keeping the object fixed, if the plane mirror is rotated in its plane by an angle theta, then what will happen is the reflected ray rotates in the same direction by an angle of 2 theta. Have this in your mind. So the deviation that is taking place in the reflected ray is going to be 2 theta, provided how much? If the plane mirror is rotated by an angle theta. Make a note of this point. Okay. Guys, are you clear?
So
Next.
yes.
Focal length as well as radius of curvature of a plane mirror is always infinity. Power of a plane mirror is 0 because power is equal to 1 by f. So 1 by 0 is, 1 by infinity is 0. Next, in the image formed by a plane mirror, the right side of the object appears as left side and the vice versa. This kind of a phenomenon is called as lateral inversion. So lateral inversion is possible only by plane mirrors. The next concept is about spherical mirror. Okay. Next. So if you talk about a highly polished curved surface whose reflecting surface is a cut part of a hollow glass sphere, then that kind of a mirror is called as a spherical mirror. Spherical mirrors are basically of two types, concave mirror and convex mirror. So which mirror has the property to diverge the incident rays?
Convex.
Convex. So concave is also called as convergent and convex is called as a divergent. So a spherical mirror whose okay, this one you know, concave and convex, right?
Sir, it's
So
opposite for lens, no sir?
it is, yes, it is.
Okay, sir.
Okay. So convex abdominal bulged surface, right? If you take a spoon, okay, if you take a spoon, you will have the portion through which you'll eat. No, you're taking the food through the concave part, and the other side is convex. Because this concept is important for refraction through curved surface. Yeah, but so some terms related to spherical mirrors are center of curvature, radius of curvature, pole. So what is center of curvature? It is the center of the sphere from which the mirror is obtained. Radius of curvature is the distance between, it's a radius of the hollow sphere from which the mirror is obtained. Pole is what? Pole is the central part of the spherical mirror. So if you take the length of the spherical mirror as L, from one of the ends exactly at L by 2, you will have pole. So if this distance is L by 2 and this distance is L by 2, then we call that as the pole. Then what is focus? When a parallel beam of light rays is incident on a spherical mirror, then after reflection, it meets or appears to meet at a point on the principal axis, which is called as the focus of the spherical mirror. Next is focal length. So the distance between the pole and the focus is called as the focal length. The relation between focal length and radius of curvature is F is equal to R by 2, provided the mirror is small. Derivation of this we have seen in CBSE, so I'm not explaining it again. So power of a mirror is given as P is equal to 1 by F. Then what is the mirror formula? 1 by F is equal to 1 by V plus 1 by U. You need to use sign conventions. Okay. This formula is derived using sign convention, and you also need to use sign convention while solving the problems. Okay. So have this in your mind, where F stands for the focal length, U stands for the distance of the object, V stands for the distance of the image. Next is, there is something called as Newton's formula for a concave mirror. Make a note of this formula also. F is equal to root of x1 into x2, or f square is equal to x1 into x2, where x1 and x2 are the distances of the object and the image from the focus. That is, see, generally the object distance and image distance are calculated with respect to what? They are calculated with respect to the pole. If suppose the image and the object distances are given with respect to the focal length, means taking the focal length as a focus as a reference point. If you know the image distance and the object distance with respect to focus, then the focal length times the focal length square is equal to the product of the distances of the object and the image from the focus. This also can be obtained using mirror formula.
Sir, so basically U is equal to F1 plus X, sir.
Either F1 plus or minus X.
Plus or minus X, okay.
Yes. Yeah. Okay. So linear magnification means what? The ratio of the height of the image formed by the mirror to the height of the object is what is called as linear magnification. For mirror, the linear magnification is minus V by U, and for lens, it is plus V by U. Remember, you have to use sign convention, though you have a minus sign here. So have that point in your mind. Don't forget it. Okay. Next, aerial or axial magnification. So what do you mean by aerial magnification? The ratio of the area of the image to the area of the object is called as aerial magnification. So aerial magnification is area of image by area of object, which is V square divided by U square. Okay. So axial magnification means name is suggesting when an object is placed along the axis. When an object is placed linearly along the principal axis, then its longitudinal or axial magnification is given by the formula minus dV by du. Have this point in your mind. See, generally the questions are not asked based on this. So principle is PAL. Okay. Questions are generally not asked based on this. They will maximum ask you aerial magnification because there is not there. But still you can know what it is. Minus dV by du. That is, if you have V as a function of U, then minus dV by du is going to give you the Axial magnification. So how all these formula are derived is 1 by f is equal to 1 by v plus 1 by u, correct? Differentiate with u on both the sides, you will get that. Okay. So sign convention, you guys know, no? All the distances are measured from the pole of the mirror. Pole is considered as the origin. Similarly, distances measured in the direction of incident ray are taken as positive. I generally don't follow this, okay? I ensure, so when you're taking the sign convention, one thing that needs to be ensured is, irrespective of whether it is a concave or a convex mirror, you need to ensure that the reflecting surface is always on the left-hand side. Okay. So in that case, what will happen is, you will always place the object on the reflecting side. So U is always negative. Okay. If you get the image on the other side, you get the V to be positive. If you get the same side, V is going to be negative. Similarly, if the focal length of a mirror is negative, then it is concave. If the focal length of a mirror is positive, then it is convex. So convex mirror has positive focal length. Okay. Next. So I hope you guys remember how to draw the ray diagrams, right? What are the rules that are to be followed to draw the ray diagrams, guys? What rules will you follow? So ray passing through the center of curvature will reflect back without any deviation. Secondly, a ray parallel
Parallel will pass through focus.
will pass through focus. A ray through focus will pass parallel to the principal axis. A ray hitting the pole will reflect back symmetrically with respect to the principal axis.
Sir, first point, sorry.
Center of curvature. Ray through the center of curvature will reflect back along.
Okay, yes.
Okay. So formation of image by concave mirror. So concave mirror has 6 ray diagrams. Convex mirror has 2 ray diagrams. Right. So with respect to concave mirror, what can you say? When the object is placed at infinity, what will happen? You will have a real inverted and very small image that is formed at F. Between infinity and C, you will have real inverted diminished between F and C. So as you keep moving closer, the image will start moving away and its size will keep increasing. Next, at C, what will happen? Real inverted equal in size at C. Between F and C, what will happen? The image will be bigger. It is still real inverted, but it will be larger and it is formed between 2F and infinity. That is beyond C. At F, what will happen? It is real inverted, very large, and it is formed at infinity. Between F and T, this is the only point where it forms a virtual image, and virtual image is magnified. It is larger in size behind the mirror. Okay, this is the only place where a concave mirror will form a virtual image. When is it? When you place the object between the focus and the pole. Next. With respect to convex mirror, what will happen? When the object is at infinity, you have a virtual, erect, and a very small size, a very small image at F. When it is in front of the mirror, what will happen? Front here, you will not have anything like between F and C like that, because all F and C are present on the right hand side. So in front of the mirror is the only concept. You will have a virtual, erect, and diminished image. This is a very important point. A convex mirror will always form a diminished image. Okay. So with this basic knowledge, let's try out few problems. So that is where you're going to understand things better. So as I told you, one point to be kept in your mind is, as this chapter demands geometry, you need to start thinking in terms of angles and trigonometry. Okay. So have it in your mind. Let's start solving. There is a concave mirror which has a radius of curvature 40 centimeter. It is at the bottom of a glass that has water filled up to 5 centimeter. If a small particle is floating on the surface of water, its image is seen directly above the glass and is at a distance d from the surface of the water. The value of d is close to. So how do we solve? The small particle is floating on the surface of water. Its image as seen from directly above the glass of water is at a distance d from the surface of water. The value of d is close to.
So இதுதானே apparent depth by real depth.
Yeah, the concept use பண்ணேன். ஞாபகம் இருக்காது?
அதெல்லாம் லைட்டா இருக்கு.
Okay, அப்போ பார்த்துக்கலாம். The concept பார்த்துட்டு we will get into it. So refraction of light, you people know, right? Incident ray, refract ray will bend towards the normal when it is traveling from rarer to denser medium. It will reflect back, it will refract away from the normal when it is traveling from denser to rarer. It's the point now. So what is the cause of refraction? It is the speed of light, which is different in different media. So what are the laws of refraction? At this point also you should know. So what are the laws of refraction?
Sir, Snell's law and then rays are in the same plane.
All done. Snell's law. Okay. Next. Refractive index definition தெரியும். So இது மட்டும் மறந்துடாதீங்க. Absolute refractive index அப்படின்னா it is ratio of the speed of the light in vacuum to the speed of the light in the given medium. Okay. அதே மாதிரி relative refractive index என்னது? It is the refractive index of the second medium with respect to the first is given as mu2 divided by mu1 is equal to v1 divided by v2. இந்த பாயிண்ட் மறந்துடாதீங்க. It is inversely proportional to the speed of the light in the medium. Next
Sir,
is
absolute நாக்க c by v v by c sir.
c by v. எப்படி ஞாபகம் வச்சுக்கணும்னா the maximum speed of light is possible only in vacuum.
Air. ஆமா.
And mu is greater than 1. Mu is always greater. Refractive index is always greater than 1. The least value is 1. Okay. So அப்படி இருக்கணும்னா c தான் numeratorல இருக்கும். அப்படி ஞாபகம் வச்சுக்கோ மறந்துடாதீங்க.
Okay sir.
Yeah. The refractive index of a medium mu is given as a plus b by lambda square plus c by lambda power 4, which is called as the Cauchy's formula, where lambda is the wavelength of light, ABC are constants, and the refractive index is inversely proportional to lambda square. ABC are generally called as Cauchy's constant. You will use this Cauchy's formula to explain why red light is bending more compared to violet. Okay, we'll explain in terms of wavelength. Next, refraction through a glass slab. So when a glass slab is placed in path of a light ray, it produces a shift in the position of the object when viewed through it, and the shift is given as t into 1 minus 1 divided by mu, where that mu is the refractive index of that particular material. Okay. When the object is in the denser medium and seen from the rarer medium normally through the plane surface, then the apparent depth of the object is given as 1 minus 1 by n into actual depth of the object in the denser medium. Okay, all these things can be derived easily. Next.
Sir, inga n no?
Refractive index. N is refractive index.
Okay.
Critical angle. When the light ray is traveling from the denser to the rarer medium, the angle of incidence for which the angle of refraction is 90 degrees. That is, the ray grazes along the surface is what is called as critical angle. And the value of critical angle is given as, so mu is equal to 1 by sin c. So sin c will be equal to 1 by mu. So c will be sine inverse of 1 by mu. Okay. So the சொன்னேன்ல this concept. The refractive index is maximum for violet light, violet color of light, and minimum for red color of light, as mu is inversely proportional to lambda. Correct? Therefore, critical angle is maximum for red color of light and minimum for violet color of light. That is, CV is less than CM. So total internal reflection, the bending back of the light into the same medium after the angle of incidence crosses the critical angle is what we call it as total internal reflection. Okay. Optical fibers, again, it will be treated like a problem, so don't worry about it. Okay, we will see this concept alone.
Sir, lateral shift வந்து 1 minus 1 by mu into T தானே sir? T for thickness.
T is the thickness of the glass slab.
Okay, sir.
Okay. Let's try this problem out. So how is mu defined as? In terms of real depth and apparent depth. Suppose you have a rarer medium and a denser medium. Let's take this as an example. So particle is placed here. The small particle is floating on the surface of its image as seen from directly above the glass at distance t from the surface. So the denser medium. If an object is placed here, you are seeing directly from here. Okay, where will the image be formed? One ray, if you take, it will come without any deviation. When you take the other ray, it gets deviated like this. So when you try to pull it back, if this is I, this is going to be R. If this is R, okay, if this angle is R, then this angle is also R. Correct? If this is I, then this angle will be I. Okay. Now tell me, what are all the laws that you can apply? Here it is mu. I'll take it as mu1 and mu2. This is the real depth. This is the apparent depth. Solra. Mu1 sin I is equal to mu2 sin R. Accepted. Snell's law. I asked you to remember it as refractive index times sine of the angle of incidence in that medium is equal to refractive index times the sine of angle of refraction in that medium. Then mu1 into I is equal to mu2 into R, or I can write mu1 into tan I is equal to mu2 into tan R, because the size of the pupil is very small, that these two rays have to be very close to each other for you to see the image as a single image. Okay. So u1 into tan I. What is tan I? If I take this as AB, tan I is AB divided by 1 minute. AB divided by AO is equal to mu2 into tan R is how much? AB divided by AI. AB gets cancelled. Mu1 by mu2 is equal to AO divided by AI. What is AO? Real depth divided by apparent. Okay, so this is the formula that we are going to use to solve this problem. Now comes an important. Now tell me, what ideas are you going to follow to solve this problem? Suppose this question comes, how will you solve it?
Sir, you gave no, sir. So இங்க வந்து real depth will be 5 centimeter, sir.
Okay, real depth munnadi, there is something else that is going to happen. No? For this particle, what will be the work of this concave mirror? We are not concentrating on it at all. So with respect to the concave mirror, what is the object distance?
5 centimeter.
-5.
-5 centimeter. If this, okay, va? அதே மாதிரி focal length எவ்வளோ?
20. Minus 20.
-20. இப்போ இதுல பார்த்தனா, like I told you, right? I'm looking at it like this. So this distance is 5. Correct? So இது தெரியும்ன்றதுனால v எவ்வளோ? 1 by f plus 1 by f is equal to 1 by v plus 1 by u. 1 by v 1 by f வந்து -20, 1 by v plus 1 by -5. So 1 by v எவ்வளோ? 1 by 5 minus 1 by 20, that will be 15 divided by 100. Or 3 by
I got 6.6, sir.
3 by 20. Okay, v will be 20 by 3 centimeter. So where is 20 by 3 அப்படினா எங்க வரும்? It is somewhere over here because the answer came out to be plus. So now this image that is formed due to the concave mirror will act as the object for whom? For the person who is seeing from the top. So with respect to the person who is seeing from the top, what is going to be the real depth?
5 plus 20 by 3.
20 by 3 added to the 5. So how much is it? 15, 35 by 3 centimeter. Okay. Apparent depth எவ்வளோ?
That is what we need to find, sir.
D.
Okay, that's what we need to find. So mu is equal to real depth divided by apparent depth. So mu எவ்வளோ? Refractive index of water is 1.33. 4 by 3 is equal to real depth is 35 by 3 divided by apparent depth. So 3 cancel பண்ண apparent depth is 35 divided by 4. 35 by 4 na less than 9. 8 point something. இருக்க option ஏதாவது? புரியுதாடா?
So I can't understand the last step, sir.
Which step? This one, huh? This is a formula.
Yes, below that, sir.
Refractive index of a medium is equal to real depth divided by apparent depth.
Yes, sir.
See, mu1 by mu2 போட்டிருக்கானடா. Generally mu2 will be 1. Okay, if I take mu2 to be 1, mu1 is equal to RD divided by AD. So real depth எவ்வளோ? Real depth is 35 by 3. This point is clear?
Yes, sir.
Why 35? So I put 35 by 3. Apparent depth is what they are asking. And refractive index is 1.33. 1.33 is nothing but 4 by 3 only. No? That's why I wrote.
Okay. Okay,
Yeah.
sir. Okay, sir.
Good problem. So let me know once you have copied it.
Sir, problem number 1 தானே sir?
இது 1 rep.
Okay.
Shall I move on to the next one? So try this, no? So there is a concave mirror for face viewing has a focal length of 0.4 centimeter. The distance at which you should hold the mirror from your face in order to see your image upright with magnification of 5. Upright none other, it is erect. Correct? So focal length, concave mirror tunnel minus 4 meter. Magnification is how much? Plus 5. Okay. So what is the formula for magnification? Minus V divided by U. Which implies V divided by U is minus 5. So from this we can get V is equal to minus 5U. Object distance na kekranga. Okay. So 1 by F is equal to 1 by V plus 1 by U. 1 by minus 0.4 is equal to 1 by V avulada. It is minus 5U plus 1 by minus U. Okay, I'm sorry. Remember in this chapter, whichever quantity is to be found, you should not use sign convention for it. So 0.4 now 4 divided by 10 minus 10 divided by 4 is equal to, this will be 5, this will be 5. So 5.
0.32 sir answer. Teriyaleda.
Irka. 0.32 with a negative sign. Yes. 4 divided by 5. Then our 16 divided by 50.
Sir, that is 0.32.
That's it.
Sir, ஒரு formula இருக்குல்ல sir, that says dv by du is equal to v square by u square is equal to f by f minus u.
That is when the object is placed linearly along the surface. இப்போ ஒரு மிரர் இருக்குன்னா object should be placed along the axis. That's called axial magnification.
Oh, sir, I substituted that here. It came, sir.
Maybe work ayirkalam, but that's not right.
Sorry, okay, sir.
Okay.
I'll use this, sir.
Better you go with this method.
Sir, you write v in terms of f and then find it, sir.
That's what, whichever parameter, because see, number of unknowns actually are end. But the advantage is since when will they give magnification is when you can write one parameter in terms of other, especially the relation between V and U can be found from it. So on the Mari. So in the question, that was the advantage. The next Puridada?
Yes, sir.
Harish, you are clear?
Yes, sir.
So there is a point source of light S, which is placed at a distance L in front of a plane mirror of width D. So there is a plane mirror whose width is D, and there is a source which is kept at a distance L. In front of the, which is hanging vertically on the wall. A man walks in front of the mirror along the line parallel to the mirror at a distance 2L as shown. So there is a man who is walking in this direction. The distance over which the man can see the image of the light source in the mirror. So that is how much distance can he walk this side and this side so that he is still able to find the image from the mirror. After he crosses this particular point or this particular point at the bottom, he will no more be able to see the image. They're asking what is the distance that he needs to cover. Let me call this distance as capital D. No. Let's try to redraw the diagram, okay? Mirror, man walking. There is no formula that you can use actually. You need to use a logic. So this is the mirror. The mirror's size is small d, and this distance capital D. S is here. So a light ray will be instant at this corner. A light ray will be instant at this corner. The reflected ray should go and meet here. The reflected ray should go and fall here. So incident, reflected. Are you guys able to understand?
Yes,
There
sir.
will be one ray like this which will go and hit it here. You will be able to see. There will be another ray here which will go and hit the surface. You will be able to see. So like that, what is the last incident ray that is possible that will actually show the image of the person?
At the
Beyond
tip.
this, at the tip. So beyond this, what will happen? Every ray is going to get deviated. Okay.
Beyond that, there is no refracting surface.
No, there is no reflecting surface. Another, the ray will travel undeviated. About to put it. Okay, this is. So this is angle of incidence. This will be the angle of reflection. Angle of incidence, angle of reflection. Okay. So this distance is L. This distance is 2L. Let's see if you're able to form any triangle. So D is nothing but, I can say this distance is D because it forms a rectangle. So this is, if I take this as capital D, what can we do, guys?
So that's it. Angle which can we do some trigonometry, sir?
You can. That's what I'm thinking. So this will be D by 2.
I and R
And
are same, no, sir? Because plane mirror.
I and R are same. So if you take this as theta, this is also theta, this is theta, this is also theta. Because it's going to be symmetric. Similarly, this distance is D by 2. This distance is going to be 2L. This distance is L, this distance is 2L. Now what can we do?
Sir, on the D இருக்குல்ல, sir. Above and below mark X, sir.
இதுவா?
The excess length, yes, sir. So then we can
Okay.
find X in terms, something like that.
X by 2L என்ன வரும்? Tan theta. So X is equal to 2L tan theta. Okay, 1. இதுல ஒரே ஒரு disadvantage என்னன்னா, I can use trigonometry when I have Snell's law. That is easier because Snell's law also uses trigonometry. So it's better we go with congruency of triangles. புரியுதா? எது சேலஞ்ச் என்னன்னு புரியுதா?
சார் ஸ்னெல்ஸ் law யூஸ் பண்ணலாமே சார். ஸ்னெல்ஸ் law வந்து என்னன்னாக்க here there is no, I mean the mu will be 1, no sir?
But it's not refraction, it's reflection.
Oh, okay.
Yeah. So either theta and edutha, this will also be theta. We got it actually. See, இது புரியுதா? theta இதுவும் d by 2 ல, இது d by 2 L. So tan theta எவ்வளோ? Tan theta is equal to d by 2L. So here tan theta is saying x by 2L. So x by 2L is equal to d by 2L. அப்ப என்ன வரும்? 2L will get cancelled. X will be equal to dr. அப்ப இதுவும் d, இதுவும் d. So d plus d plus d is 3d.
3D.
புரியுதா?
சார்
புரியுதா?
ஸ்டெப்ஸ் காட்டுறீங்க ஒரே நிமிஷம்.
So what I did, I took this bigger triangle. When I take the bigger triangle, நான் வேற கலர் யூஸ் பண்றேன். When I take the bigger triangle, நீ சொன்ன மாதிரி I took it as x. X divided by 2L என்றது என்னது? tan theta. அது புரியுதுல? அதே மாதிரி if I take the smaller triangle, tan theta is nothing but d by 2 divided by L. That is also d by 2L. So inge tan theta is x by 2L, inge tan theta is d by 2L. So since tan theta is the same, x by 2L is equal to d by 2L, cancel it, x is equal to d.
So one
See what's
second,
in
I got
Puri?
it, sir. Yes, sir, I got it.
முடிச்சிட்டியாடா?
முடிச்சிட்டேன் சார்.
Let's try this. The plane mirrors
சார் அந்த
M1.
क्वेश्चनல வந்து congruency விட you can use similar triangles நினைக்கிறேன் சார்.
Yeah, similar triangles. Congruence பண்ண முடியாது. Similar தான் பண்ண முடியாது.
So அதே triangles construct பண்ணத
you have to construct triangles.
Yes sir.
See, I'm more comfortable with trigonometry than Euclid's geometry. So now I use it. Okay. So that's actually easier, and trigonometry is more accurate.
Sir, yes sir.
Yeah. So plane mirrors M1 and M2 are inclined to each other such that the ray of light incident on the mirror M1 is parallel to, wait, we have to draw. The plane mirrors, I'll draw a better diagram. So I suggest you guys also to try parallelly. There are two plane mirrors, M1 and M2, which are inclined to each other such that a ray of light incident on the mirror M1 and parallel to M2 is reflected from M2 parallel to M1. Okay. So there is a ray incident on M1. Okay. This ray is parallel to whom? Is parallel to M2. So obviously, since it has hit a mirror, it will undergo a reflection. Once it hits, after reflecting, once it hits mirror M2, now this reflected ray will be parallel to M1. புரியுதாடா? No. So let's try this. So what are they asking? The angle between the two mirrors, theta, is how much? Let's think. Every corner. So if this angle is taken as theta, then this is a line parallel to M1, this is a line parallel to M2, then this will also be theta. If this is theta, this angle is vertically opposite, this is also theta. Correct? This theta nu edutha, then if I complete a triangle, then this angle is 90 minus theta and this angle is theta. Puriyada? Similarly, if this is 90 minus theta, this angle will also be 90 minus theta according to the principle of reflection, and this will be theta. Then, how much is this total angle? If this is theta, here the total angle is 180 minus 2 theta, then how much will this be? 180 minus of 180 minus 2 theta plus theta. Cancel it. Is it still theta? Theta In the angle is okay. I've taken all the possible angles. Then this is also theta. அப்ப இந்த angle எவ்வளோடா? 180 minus 2 theta plus theta. It's coming out to be theta only, no? Am I missing something? Yeah, am I missing something?
சார் ஆப்ஷன்ஸ் என்ன சப்ஸ்டியூட் பண்ணி பார்ப்போம் சார்.
அப்படி பண்ணி பார்த்தாலும் வேலைக்கு how will you get? பண்ணி பார்த்துட்டு என்ன பண்ணுவேன்? இல்ல ஆக்சுவலா இட்ஸ் மை மிஸ்டேக். இது 180 minus 2 theta னா அப்ப இந்த ஆங்கிள் எவ்வளோ? ஏன்னா இது 90 இல்ல. So 90 minus of 180 minus 2 theta எவ்வளோ? It is minus 90 plus 2 theta. So இந்த angle வந்து 2 theta minus 90. This angle is also 2 theta minus 90. So 4 theta minus 180 is actually theta. ஏன்னா அப்பதுல இருந்து பார்த்தா நம்மளுக்கு theta தான் வருது பத்தி இந்த total angle. So 480 minus 180, 4 theta minus 180 is theta. Then 3 theta is 180. Theta வந்து 60. இருக்காடா 60? The answer. நான் என்ன பண்ணேன்னா I was rotating using the law of triangles, but I forgot that this is a normal. And the concept use பண்ணியிருந்தா I would have got the answer long back. புரிஞ்சுதா நான் என்ன பண்ணேன்னு? Did you guys understand? M2 is like this. No? M2 is like this. Na? This is the normal, right? இப்படி ஒரு ரே போதா? Let me call that ray as AB. இது A, இது B ன்னு எடுத்துக்கிட்டேன்னா இது 180 minus 2 theta. இதெல்லாம் புரியுதா? அது புரிஞ்சுதா?
Yes, sir.
180 minus 2 theta னா அப்ப இந்த ஆங்கிள் எவ்வளவா இருக்கும்?
90 minus 180 minus 2 theta.
அப்ப வந்து 2 theta minus 90யா?
ம்.
இது 2 theta minus 90 னா ரிஃப்ளெக்டட் ரே கூட 2 theta minus 90 தான பண்ணும். And this angle is theta. கரெக்ட்டா? அப்ப இது எல்லாத்தையும் ஆட் பண்ணா how much should I get? 180. So theta plus 2 theta minus 90 2 times plus 180 minus 2 theta is nothing but 180 linear pairல. So theta plus 4 theta minus 180 plus 180 minus 2 theta is 180 அப்படின்னா cancel it. 2 theta plus theta is 3 theta is 180, which implies theta is 60. புரியுதா? Actually, it's a simple problem. கூட புரியலையடா.
Got it, sir.
சார் எப்படி எல்லாமே 180 சார்?
ஸ்ட்ரெயிட் லைன்ல.
ஓ ஓகே ஓகே ஓகே. நவ எஸ் சார்.
Then shall I move on to the next one?
Yes sir.
Okay. Let's try the next one. There is a ray of light traveling in the direction half into I cap plus root 3 j cap, which is incident on a plane mirror. After reflection, it travels through a direction of half into I cap minus root 3 j cap. The angle of incidence is normal. Let me take this as origin. Half into I cap plus root 3 j cap. Now, which quadrant is it? So it is entering into the first quadrant. This is the angle of incidence. Okay, if this is R, then how much is this? This is 90 minus R. This is I, this is also I. Then this will be 90 minus I. So I plus 90 minus I plus 90 minus R plus R, it's obviously 180. See, since they are given as two vectors, can I find cos 2 theta? See, since I is equal to R, if I find cos 2i, I will get the angle between those two vectors. Now, what is the formula for cos 2i? 1 by I into, that is C. Cos theta is equal to A vector dot B vector divided by magnitude of A vector into magnitude of B vector. So, half into 1 minus root 3, the whole divided by magnitude of it, 1 by 2 into 2 plus 1 by 2 into 2. Cancel, cancel 2 times. So 1 by 4 into minus so minus half is what is cos 2i. Since angle of incidence has to be acute, I am taking the modulus of it. So 2i will be 60 degrees and I will be 30 degrees. Irukada 30 option. It's an advanced problem. Guys, I hope you are clear with what I did.
திரும்ப காட்டுறீங்களா?
இந்த ஃபார்முலா புரிஞ்சா என்ன பண்ணுங்க?
அது வெக்டர்ஸ் டாட் ப்ராடக்ட்ஸ்.
Yeah, that's what it is.
சார்
So
டாட் ப்ராடக்ட் பண்ணும்போது 1/2 into 1 minus 9 வராது. ஓ
root
ரூட் 3.
3
நான் 3 எழுதிங்க சாரி.
got it.
Yes sir.
Next, we'll try out some problems based on refraction. Try பண்ணலாம். So problems கொஞ்சம் tough தான் இருக்கும், but let's try it out. Okay. So transparent cube of psi d made of a material of refractive index mu2 is immersed in a liquid of refractive index mu1. Mu1 is less than mu2. Okay. A ray is incident on the face AB at an angle theta shown in the figure. The total internal reflection takes place at point E on the face BC. Then theta must satisfy. Okay. So how to do? So let's try to proceed. So if this angle is theta, okay, if this angle is theta, so where is the inga vandu pathana at this point there is refraction and E is the point where is reflection. So in the angle evlava irukum? It should actually be a value which is greater than C, which is greater than the critical angle. Then how much is this angle? It will be 90 minus C. Correct? So if I take this point P, if I apply Snell's law at point P, mu1 into sin theta is equal to mu2 into cos C. So lama. So sin theta divided by cos C is equal to mu2 divided by mu1. Our interest of study is about theta. So mu2 by mu1 times cos C. What is cos C? Mu2 by mu1 into root of 1 minus sin square C. How to find the critical angle at this point? So sin C is equal to 1 by mu2. So mu2 divided by mu1 into root of 1 minus 1 by mu2 square. That is 1 by mu1 into root of mu2 square minus 1. So root of mu2 square minus 1, if I push the mu1 inside, root of mu2 square divided by mu1 square, the mu1 minus 1. So this is theta. So theta is equal to sine inverse of root of mu2 square by mu1 square minus 1. Here is option. theta is equal to mu 2 square by mu root of mu 2 square by mu 1 square minus 1. Similarly, what can we say is for total internal reflection? இது வரைக்கும் புரியுதாடா? So what are the condition to be satisfied for the total internal reflection to take place at point E? The angle of incidence at point E is supposed to be greater than the critical angle. Here we have considered it to be equal to the critical angle. Correct? If it has to be greater than the critical angle, then the value of theta should be less than sine inverse of root of mu 2 square divided by mu 1 square minus 1. Because this step tells that. Okay,
Sir, sin square c க்கு என்ன சப்ஸ்டிட்யூட் பண்ணீங்க?
mu 1 by mu 2, mu 1 square by mu 2, mu 1 by mu 2 கூட. ஏன்னா sin c ன்றது என்னது ஆக்சுவலா? c is critical angle that I considered. Critical angle இருந்ததுன்னா இங்க angle of refraction would have been 90 degrees. அப்ப mu 2 into sin c is equal to mu 1 into sin 90. அப்ப sin c வந்து equal to mu 1 by mu 2.
Okay, okay.
அதுதான் இங்க போட்டுருக்கோம். Okay. புரியுதா? Let's try one more problem. So there is a ray of light AO in vacuum which is incident on a glass slab at an angle of 60 degrees and refracted at an angle of 30 degrees along OB as shown in the figure. Okay, optical path length I have to explain it. That we will see later. Next. Third. You try pananga. So in the figure, the optical fiber's length is 2 meter long and has a diameter of 20 micrometer. If a ray of light is incident at one of the ends of the fiber at theta is equal to 40 degrees, the number of reflections it makes before emerging from the other end is close to how much? The refractive index of the fiber is 1.31 and sine 40 can be considered to be 0.64. How to proceed? Huh? So for you, this total length is given as how much? 2 meter. 2 meter. It's a 2 meter optical fiber and its diameter is only 20 micrometer. We need to find out how many reflections have taken place before the ray is actually coming out from the other end. So how to solve? So first, refractive index vandale, whether it is useful or not, apply Snell's law. Outside medium's refractive index mu1, inside is mu2. So mu1 times sine theta 1, theta 1. So if this is the case, mu1 times sine 40. is equal to mu2 times sine of
theta 2 தான் சார்
theta 2 வரும்.
-90 minus theta 2.
இது நார்மல் எடுக்கிறோம்ன்றது தான் கொஸ்டின். ஸோ mu1 into sin 40 எடுத்தா see this is an optical fiber. இதோட thickness வந்து they have given it as 20 micrometer. Is there anything that I can make use of? Sin theta 2 தான் correct. Let that be equation number 1. Similarly, so mu1 என்றது எவ்வளவு? mu1 is air medium. So sin 40 is equal to mu2 ஓட 1.31. That is the refractive index of fiber. 1.31 into sin theta 2. So sin theta 2 எவ்வளவு? sin 40 எவ்வளவு கொடுத்திருக்கான்? 0.64 divided by 1.31. So theta 2 எவ்வளவு இருக்கும்? 0.64 by 1.31. Is it not approximately half? So theta 2 and can I consider it as 30 degrees? So theta 2 at 13 edutha, if I take this angle as x, then this is the diameter. Then tan of 30 degrees is equal to d divided by x. D equal 20 micrometer. So 20 micrometer. Up x equal 20 times root 3 micrometer. Correct. 20 times root 3 micrometer. Appa number of reflections evlo varukunda? N times 20 into root 3, is it not equal to 2 meter?
2 by 20 root 3 micrometer.
2 by 20 root 3 should be the answer. Approximate adana ketirukanga because you are not getting 0.
Yes sir, yes sir.
Approximate value da varum that you people calculate. I think the answer should either be 55,000 or 57,000 because they are close by. They'll give it to confuse you. Okay. So this is all about refraction. So we'll try some more problems tomorrow. So tomorrow we'll
5-7 sir. I think 5-7.
5-7. That's the answer.
Yes sir.
So practice பண்ணிட்டு வாங்க. I'll see you guys tomorrow.
Sir, இப்போ கேக்கட்டா அந்த டவுட்?
இப்போ
Can I ask that? Yes sir.
Yeah, you can.